So hello everyone, welcome to our channel. So today we are going to see about Dijkstra algorithm. So this is one of the important question in the data structures paper. So let's see in detail about this algorithm. Okay, so first let's see about the Dijkstra algorithm definition. So it is a shortest path algorithm. So this is going to find the minimum distance from source node to the all other nodes. Means from source node we are going to traverse to other nodes and we are going to find the minimum distance, and it is a weighted graph with non-negative edges. Means let's consider this example. If you see a b c d e f, these are the nodes, and the lines connected to each node, these are called edges, and the numbers, if you see 4 1 2 8 6, so these are the edge weights, and this should be non-negative number as per the definition. Okay, let's see the step 0. It is first is an initialization. So from which node we are going to start? So we are going to start from node A. The distance we are marking it as 0 and visited as no. And B C D E F, we do not know the distance yet, so we are marking it as infinity for now. And visited as no, we haven't visited any node yet. So first we are going to visit A, it is a start node, so we are saying the distance as 0 and visited as yes. And from A to B, if you see the distance edge weight is 4, so we are marking the distance as 4 and visited as no, because we haven't visited the node yet, we are just marking the distance of the nodes from A. So from A you can see we can A is connected to B, D and E. If we see the distance A to B, it is 4, from A to D it is 1, and from A to E it is 7. So we are marking that here in the table and visited as no as of now. And in step 2, if you see, we are going to visit from A to D. So A to D is 1, which is the smallest distance, because if we want to traverse to D, if you see the distance as 1 only, which is smaller, so we are marking as 1. Okay, so from A to D it is 1 and we are marking it as visited. And in step 3 we are going to visit from A to E. A to E distance, if you see, it is 7. So there is one other possibility to go to E, which is from A to D and then from D to E. If you see the distance, A to D is 1 and D to E is 2. So 1 plus 2 is equal to 3, which is smallest than A to E, which is 7. So we are marking the distance for E as 3 and visited as yes. And in step 4, if you see, we are going to mark the distance for C. If you see, from A to C the distance is 6. So A to B is 4 and B to C is 2. 4 plus 2 is equal to 6, and we haven't visited that yet. We are marking it as no. Okay, then we are going for step 5. And step 5, if you see, we are going to find the distance of F. So the distance of F is, from C to F it is 10. So let's find other possibility. From A to F, if you see, the distance is 1 plus 6 is equal to 7. From D to F it is 6. So that is the smallest distance as we can see in the graph. So we are marking the distance of F as 6 and visited as yes. To see what is the distance, to go to C, what is the distance, minimum distance required, right? So we are going to find that. So to C, the distance we are marking as 6. From A to C, 4 plus 2 is equal to 6. So we are marking as 6 here. So here, if you see the shortest distance from source A is equal to 0, B is equal to 4, C is equal to 6, and D is equal to 1, E is equal to 3, and F is equal to 6 as per the step 6. We are marking the distance of each and every nodes. So the shortest path will be in the ascending order. So from A to B, and then from A, B, C, and then A to D, and then A to 3, and then A to D to F. So we are marking the shortest path as shown below. So this is how we find the shortest path using Dijkstra algorithm. So hope you got the clear understanding. So if you have any suggestions to improve this, you can give that in the comment box. Thanks for watching.